Hello pre-calculusers. We are going to talk about quadratic equations today. You've been seeing quadratic equations for a number of years. I hope this will be old hat to you. If, depending on what you took last year, you may or may not have experience with completing the square. So that might be new to you. Everything else should be repeat. We'll talk about completing the square. We'll review factoring a little, solving by graphing, quadratic formula, and then talking about the discriminant. To complete the square, completing the square is based on the fact that if you have an equation with both a squared part and a linear part and then a number. Actually, this one wouldn't work. You can't solve it in the normal way you solved linear equations, where you would just move part of it and then get the x by itself. And you can't solve it as you would if it was just like this, where you could take the square root. So the best way to solve it is make it so that one side is a perfect square, and then you can take the square root and get the x by itself. So that's what you want to do. We want to make one side a perfect square so that we can take the square root of it. And there are some steps for doing this. Get the equation so that the coefficient of x squared is 1. This will mean you have to divide everything by your coefficient if it wasn't 1. So b over a times x, and then get your constant on the other side. So I'm going to do example 1 here. The first thing I want to do is divide everything by a. So this will become x squared plus 3x plus 5 over 2 equals 0. And then I want to get the, to move this 5 over 2. So x squared plus 3x equals negative 5 over 2. That's step 1. Step 2, add b over 2a squared to both sides. It sounds a little confusing, but what it means is step 1 says divide everything by your leading coefficient and then get the constant on the other side. Step 2 says, alright, now divide this by 2, cut it in half, square that, and add the result to both sides. So we will cut 3 halves, cut 3 in 2. So x squared plus 3x plus 3 over 2 squared, and I'm going to leave it like that for right now, equals negative 5 over 2 plus 3 over 2 squared, because you have to add it to both sides to make sure the two sides are still equal. Now, because of the way you did this, because you cut this in half and squared it, this is now a perfect square trinomial. That is, it's a perfect square trinomial. What do you want me to say? All right, so what would add up to 3 and multiply to 3 halves squared? Well, 3 over 2 plus 3 over 2. So we can rewrite this side as x plus 3 halves squared. It's probably easier to see with an easier function, but trust me that this works. We can talk about it in class if you're at all confused about it, but this is the basic deal. Now over here, this would, when you square it, this turns into 9 over 4. To add them, we need like term, or we need the same denominator. So this will become negative 10 over 4 plus 9 over 4. So now we've got negative 1/4 on the right-hand side. X plus 3 halves squared equals negative 1/4. Now, this is a perfect square trinomial. What can we do? We can take the square root. So, take the square root of both sides, use plus or minus. Please don't forget that. So now we've got, on the left-hand side, we have x plus 3 over 2, and on the right-hand side, we have plus or minus the square root of negative 1 over the square root of 4. The quotient property with radicals says that we can split it up this way, and it'll make our lives easier if we do that. Then the last step is to subtract this from both sides to get the x by itself. That is, solve for x. So this becomes x equals negative 3 over 2 plus or minus, well, the square root of negative 1, that's I. We have a letter for that. And the square root of 4, that's 2. So negative 3 over 2 plus or minus I over 2, or to combine them into one thing, negative 3 plus or minus I over 2. That is your solution. Remember, a second degree equation has two complex roots, so one is negative 3 plus I over 2, and the other one is negative 3 minus I over 2. We will keep practicing that. Those of you for whom it is new, I understand that can be a little complicated. Factoring. So you may have seen this a number of different ways. The goal here is you want to figure out how to split this into two pieces, which add up to this and multiply to the product of this coefficient and this number. Since here this coefficient is 1, we don't have to worry about it. So we need two numbers that add to negative 6, multiply to negative 16. You should have had lots and lots of experience with factoring, so this shouldn't be any surprise. We're going to split this into negative 8x plus 2x minus 16. So negative 8 plus 2, that adds up to negative 6. And if you multiply negative 8 and 2, you get negative 16. Now we factor by grouping. We say, what do these have in common? Well, they both have x, so we'll factor out an x. And what do these have in common? Well, they're both divisible by 2. If we factor out a 2, we get x minus 8. By the way, if they didn't have anything in common, we would factor out a 1. You always want to take something out. And then these are the same, so we will factor that out. X minus 8 is one of our factors, and the other factor is what you get after you take that out. That is x plus 2. So if x minus 8 times x plus 2 equals 0, then either x minus 8 equals 0, which means x is 8, or x plus 2 is 0, which means x is negative 2. So those are our two solutions, x is 8 or x is negative 2. Now the problem with factoring is it doesn't work with everything. You would not be able to get this answer, for example, by factoring. You can only get it when it has not only real roots, not only rational roots, only when it has integer roots can you factor. Well, sometimes fractions, but mostly just integer roots. But if you can factor it, it's easier. So there is that advantage. Now, if this is looking unfamiliar to you, if perhaps you had me for Algebra 1 and I didn't do much, if any, of this, what you may be thinking of is the big X. Remember, the big X says we want to multiply these things, 1 and negative 16. We'll put the negative 16 up here. And the middle coefficient we put down here. We find the two numbers that add up to this, but multiply up to that, negative 8 and 2. If there was a leading coefficient, we would divide by it. It's just 1, so it doesn't change anything. So then our factors are x minus 8 and x plus 2. We get exactly the same result this way. The big X is just a shorthand for doing this, a little like synthetic division is a shorthand for doing long division. You should always get the same answers. It does the same thing, but it's a different way of organizing the process. We'll review some of this too, because especially if you're not familiar with factoring by grouping, we should talk about it a little more. All right, graphing. I'm not going to demonstrate it, but this is great, but maybe even more than factoring. It only works for certain roots, so it won't work for anything. But any real roots will appear in the calculator graph as x-intercepts. You enter the related function into y, so here you would put in y equals x squared minus 6x minus 16. Then use either second calc and then 0, and then tell it a left bound and a right bound and a guess. Or also graph y equals 0 and then find out where the graph of this and the graph of your function intersect by doing second calc intersect. Pick the first curve, pick the second curve, and take a guess, and it'll tell you where they intersect. Usually there are two roots. You need to do whichever one you choose. You need to do it twice to get both roots. But again, if the roots are imaginary, they won't even show up on the graph, and you certainly can't find them using any of the calculator functions. And if they're fractional, this is going to give you, it'll show up, but that is if it's real but irrational. or even rational, even some very good fractions, they will show up, but you will have to get the nearest decimal, and that's not the exact value, remember. So we will talk about it in class. When it works, it's great, but it doesn't work for everything. Quadratic formula you use for equations of the form x squared plus bx plus c equals 0, negative b plus or minus blah blah blah. This actually, you're used to using this. You've used it in Algebra 1 and Algebra 2. This comes from completing the square. And I will show you that in class. If you use completing the square on this general form of the function, you get this equation. The way to remember it, if you have any trouble with it, you can sing it to Pop Goes the Weasel. So, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So there you go, my beautiful singing voice. It's just a way to remember it. Quadratic formula works anytime completing the square works because they are mathematically the same. So, graphing is easiest, factoring is second easiest, but these only work sometimes. Quadratic formula and completing the square work always, even when your result is something messy like that. Last for this little video, and then I will put the answers to the guided practice in another video. The discriminant. The discriminant is part of the quadratic formula. It's the radicand, that is the part under the radical, and it tells you the nature of the roots of the quadratic equation or the zeros of the related quadratic function. What does that mean? It means if this part turns out to be negative, you're going to take the square root of a negative, you're going to have an imaginary answer. If it's positive, you take the square root of a positive, and since you're doing plus or minus, you're going to have two real values. If it's 0, square root of 0 is 0. Adding 0 and subtracting 0 are exactly the same, so you get just one root because it's actually a double root. So the rules are, if the discriminant, that is b squared minus 4ac, is greater than 0, positive, then you have two real roots or zeros, and the graph will look roughly like this. It could be this way or it could be that way, but regardless, it crosses the x-axis in two places because there are two real roots. If the discriminant is equal to 0, then you have one real root, because adding 0 and subtracting 0 is the same thing, and it'll look like this. It will touch the x-axis in only one place, kind of skims off it and bounces back up. Technically, you have two roots, they're just the same, so there will be one real root. And if the discriminant is negative, you'll have two imaginary roots, and it will never touch the x-axis at all. Finally, the conjugate. Conjugates are very useful. They'll come up here and there. The conjugate of an imaginary number has the same real part but the opposite imaginary part. These are very useful because multiplying a complex number by its conjugate always results in a real number. It's also important to know because if you have a complex root, its conjugate is also a root of that function. Negative 3 plus I over 2 is a root, then so is negative 3 minus I over 2. Technically this is true if it's real as well, but since this part would be 0i, it doesn't make a difference. So what are conjugates? Really, really easy. If 3 plus I square root 2 is your root, the conjugate is 3 minus I square root 2. Is that easy or what? If it's positive 2i, that is 0 plus 2i, then the conjugate is negative 2i, 0 minus 2i. If it's negative 5 minus 2i square root 13, still all you change is this internal sign. Your conjugate is negative 5 plus 2i square root 13. That's all for the moment. I will put up the next part in a separate video.